Hello Mr. Chung in class. My name is Adam Grieco and the purpose of this video will be to provide a step-by-step explanation of how to complete the problem that has been assigned to me. The question I was assigned and will be taking a closer look into is on page 117, number 7, A to D, in the grade 12 Nelson Advanced Functions textbook. The following question reads, use a graphing calculator to graph the equation y equals 5x to the power of 2 plus 3x plus 7. Then use your calculator to estimate the instantaneous rate of change for each value of x. For a function, the instantaneous rate of change at a point is the same as the slope of the tangent line. That is, it's the slope of a curve. The purpose is to see how the y values change according to the x values. To solve the following problem, I will be taking these 4 steps. Number 1. Add/subtract 0.01 to the number to get the x values. Number 2. Plug in the x values to the original function to get the y values. Number 3. Use the slope formula of y2 minus y1 all over x2 minus x1. Number 4. Plug in the corresponding values and solve. The first part of the question instructs to use a graphing calculator such as Desmos to get a visual of your graph. Here is what 5x to the power of 2 plus 3x plus 7 looks like on the graph. The graph shows how it would look like before we calculate the IROC of the given x values of minus 4, minus 2, minus 0.3, and 2. By the end of your calculations, you will have an idea of what effects it has on your graph. Part A, the question states, determine the IROC at x equals negative 4. So following the steps shown before, we're going to start with adding and subtracting 0.01 to negative 4 to get our x values, as stated in step 1 previously. Now, once you have both your x values, you're going to want to plug in the first x value into your original equation, which was 5x2 to the power of 2 plus 3x plus 7. Once you come up with this answer, you will have your first y coordinate. It is quite important to not put the whole equation into your calculator at once, but to break it up into sections to get an accurate answer. Making sure you are precise when it comes to your calculations is crucial to being correct at the end of this problem. For your first y coordinate, you're going to get 75.037005. Now for your second y value, you're going to do the exact same thing you did for the first y value. You plug in your second x value into the original equation to get your second y value. For your second y coordinate, you're going to get 74.963005. Now those are the 2 points you're going to be using in the final step of this problem. To finish this off, for part A, you need to use the equation y2 minus y1 over x2 minus x1, which is a slope equation. You then plug in the values you found in the first part of the problem and solve. You're going to come up with a final answer of negative 37. We did for part A. However, just for a different x value, which is 2. You're going to start off by doing step 1, which is adding and subtracting 0.01 to 2 to get your x values. Now that you have your x values, you're going to sub in your first x value, which is 2.001, into your original equation to get your first y value. Your first y value is going to come out to 33.023. Now that you have your first y value, you're going to move on to your second y value using your second x value by subbing it into your original equation. For your second y value, you're going to get 32.977. Now, on to the final step. Using the two coordinates that you just found, you're going to sub it into the slope equation, y2 minus y1 all over x2 minus x1. Once you've done this, you sub in the values that you got in the first segment and sub them into the equation and solve. So for a final answer, the instantaneous rate of change is 23. For 7C, we're going to do exactly what we did in 7A and 7B. To start off with step 1, you're going to add and subtract 0.01 to the x value of negative 0.3 to find the two x values. So to start, you're going to use the first x value of negative 0.301, and your second x value is going to be negative 0.299. So you'll sub in 0.301 into the original equation to find your first y coordinate. For the first y value, you're going to come out with 6.55. Now, next step is to sub in 0.299 negative into the original equation to get your second y value. Now for your second y value, you're going to come out with the exact same value of 6.55. On to the final step. To figure out the instantaneous rate of change, you have to use the slope formula of y2 minus y1 over x2 minus x1. The final step is putting in the four values that you have and solving. So the IROG of negative 0.3 is 0. Now for 7D, the fourth and final part of the problem, we're going to be finding the instantaneous rate of change for negative 2. So as we've done for the last three, the first step would be to add and subtract 0.01 to your x value, which is negative 2, to get your x's. Now, once you have your x's of negative 2.001 and negative 1.999, you're going to sub in your first x value, which is 2.001 negative, into your original equation, which will give you your first y coordinate. For your first y coordinate, you're going to get an answer of 21.017. Now the second step is to sub in negative 1.999 into the original equation to get your second and final y coordinate. For your second y coordinate, you're going to get 20.983. Now that you have both of your points, you're going to sub them into the slope equation, which is y2 minus y1 over x2 minus x1. So by subbing in your two coordinates into that equation, you'll be finding the instantaneous rate of change of x equals -2. A rate is a ratio between two measurements with different units. A common example of a rate is speed, which is written in kilometers per hour. You can see that this describes the relationship between the two measurements, kilometers and hours. In fact, we use rates all the time in everyday life, and they can be really useful. For example, we use rates to calculate how much money you earn in a week, how far you can go on a tank of gas, or how many cars a company can make per hour. A very practical and simple example would be running a business, and IROC can help you decide what quantity you should sell. Given the data of your business over a few months, you can calculate the data and draw a curve to see the trend.